Direct Connection is made by MPT to serve all of our diverse communities and is made possible by the generous support of our members. Thank you. Live from Maryland Public Television, this is Direct Connection with Jeff Salkin.
Hi, everybody. Thanks for tuning in for Direct Connection. Tonight, our focus is the biggest of the big questions. Are we alone in the universe? Many at NASA think the answer is no, and that they'll be able to prove it within the next 20 years. Joining us tonight is the director of the Space Telescope Science Institute, Matt Mountain. Dr. Mountain, thank you for being with us.
A pleasure, Jeff. Thank you.
I understand that 20-year prediction was your 20-year prediction.
It was one of those predictions I made. We were trying to get people excited about it. And actually, I think it's a fairly credible number because the technologies and the science are all beginning to converge. And if we sort of get our act together and actually make these measurements and able to do the equipment, I believe it is within 20 years. We'll at least know whether we are alone or not, because we, of course, don't know whether there is actually life out there.
In your heart of hearts?
Well, you see, here's the problem. We know there are an awful lot of stars out there. And from an astrophysicist perspective, you can say, well, there's so many stars out there. In fact, 10 to the 22, that's 1 with 22 zeros. You say, well, surely there has to be life out there. So that's an astrophysics view. You ask a biologist, and they say, well, do you know how many coincidences have to happen for life to form? So it actually turns out to be, you know, my heart says it would be great. My mind says we're going to have to find out because there are so many big uncertainties. It could be nothing or everywhere. And we actually don't know. And the difference is 1 part in 10 to the 22, which is a pretty big error even for physicists.
Let's start with the big picture on this. Literally, the big picture is from the Hubble's, this is the wide field camera?
Ultra deep field. It's from the wide field camera, yes.
Now, it looks to me like that's a bunch of stars, but if I look closely, you start to see that some of them are spirals, and those must be galaxies.
In fact, they're all stars, ultimately, but the most amazing thing about this image, it was taken by staring at a blank piece of sky no bigger than a drinking straw. And they stared for 10 days at this area of the sky, and what they saw was this, which is 10,000 galaxies. There are, in fact, only 3 individual stars in this whole image. Every other single point of light there is a galaxy of at least another 100 billion stars. And this told us how big the universe is for the very first time. We realized how crowded it is in galactic, supergalactic scales. It tells us there's roughly 100 billion galaxies in our observable universe. And we didn't know that until we took this image.
And you said it's the equivalent to looking through a drinking straw. It's
yeah,
that sliver of the sky.
That small thing. You just look up at the dark sky through a drinking straw, a little patch of light. You had a Hubble Space Telescope, and you looked at that little patch of light for 10 days, you'd see 10,000 galaxies in that single patch of light.
The Hubble has been a remarkable thing. It was off to a slow start. People may recall 24 years ago when it was first launched. But even with its age, and I know there's some new equipment, the pace of discovery doesn't seem to have slowed.
No, I mean, if anything, it's exploded. I mean, you know, it's when the Hubble started, we didn't know how big the universe was. We didn't know if anything about dark matter or dark energy. We didn't know about planets. We didn't know about black holes. These are all guesses and theories. Today, we know the universe is 13.7 billion years old. We know that galaxies are everywhere. They change with time. We know the universe is pervaded with this strange stuff called dark energy, which in fact was discovered by a physicist at Johns Hopkins. And we see dark matter everywhere, distorting the light. And now we know that there are planets around other stars everywhere.
And the pace of discovering planets has ramped up exponentially, and that's not necessarily Hubble, that's another telescope, right?
It started with the Hubble.
Of course it's Hubble.
Of course it does. It always starts with Hubble.
And knowing where to look.
Well, actually, to be fair, 15 years ago, we really didn't know how many planets there were, if they were even really existed. People started looking at wobbles of stars and just, maybe 1 or 2. Then the Hubble actually looked at a patch of sky towards the galactic center and stared at 180,000 stars and saw small dips on about 17 of them. You think, well, that's not a very big number. But that's because these planets were going in front and making it slightly dimmer. And that told us there were 5 billion Jupiters in our galaxy.
Let me just let Dwight know. I think that's number 5 is the center of the galaxy, if we could pull it up, which is just another big image full of a lot of dots.
That is real stars. That is just stars.
So this is looking inward.
Inward towards our galaxy. And you just and the Hubble stared at this for a whole week and just said, is the light going to change by less than 1%? And this told us, and 17 of those little dots you see there, their light dimmed every sort of few hours or so over the period of a week. And that told us that, in fact, there were 5 billion Jupiters in our galaxy.
So there was something going in front of the star that
just
made
in front,
just a little bit dimmer.
Just a little bit dimmer. As it goes in, just a little bit dimmer. And the Hubble is so stable that it could detect that little bit of light just as you go. So here's my hand, and there's the thing that goes striking past. You just get a little bit of a shadow.
And as a layman understands it, as you refine the technique and improve the technology, from that little change in light, you're going to be able to tell something about the planet.
You can
that
tell
went in front of the
you
star.
can tell its size and how far away it is. And so that led NASA to launch another satellite called the Kepler satellite, which did this amazing job over the last 5 years, and has told us now there are 100 billion planets in our galaxy alone. And we didn't know that 5 years ago. So now, when you go out to look at the night sky, there's roughly 200 billion stars in our galaxy. Look up at the night sky, you know that at least every other star you see has a planet around it. And we didn't know that 5 years ago. So that's how radical this has become.
The next couple of images that we have are galaxies at great distance, and then one that's actually closer up.
So let's get a sense.
This is the closer one.
This is the closer one. This was actually discovered back in the 17th century with a telescope, and this is an image that we took with the Hubble and an amateur astronomer together, working together, making this image. And what you're seeing is a galaxy that's roughly 20 million light years from here, and you can see individual stars forming. That's what that red and the blues are. And so you can see that these galaxies have active lives, if you like, for the stars.
So this thing is alive, whether there's organic life.
What we do, all we know is that stars are being formed and they're dying in this galaxy. And so that tells us that there are stars everywhere, as there are galaxies everywhere.
And in the center of it
is a black hole.
And that's always the case?
In most of the big galaxies, there's always a black hole. And this, in fact, is called an active galaxy. It actually has a radio jet coming out of it, which we can't see with the Hubble. So we know there's a black hole right in the center of this one.
Let me remind our viewers, if you have a question about the Hubble telescope, exploring the universe, the potential of life out there, give us a call. We'll have the number up on the screen. You could also tweet a question. Our Twitter address is @MPT News. Let me take a look at the prettiest picture you brought along, which is called the Horsehead Nebula, which is probably after this one. Which is, and the Horsehead Nebula is something, this image, which maybe I had seen before in different form, but this is relatively new.
This is relatively new. What you've probably seen before, this is in the constellation of Orion, and it's a cloud of dust rising, being eaten away by stars. And what you've seen before in optical light is that where you see that orange and blue, it's just black. It's like a shadow, because we couldn't see through it. And we know that in that region, stars are being formed. What we're seeing here is an infrared view taken with Hubble's new infrared camera that allows us to look in through it. And you see this filamentary structure. And so it's roughly 2 light years across. So it takes light 2 years to get from the top of this thing to the bottom.
How much artistic license is there in preparing an image like this, where you're combining different wavelengths into something that we could see? If we were to go look at this, that's not what we would see.
Not because in this case, because our eyes are not sensitive infrared, what you would see would just be a black shadow roughly that size. So what we've done here is that we've encoded the different infrared wavelengths into light that we can see and shifted it down so you could see it. So if you had infrared eyes, this is what you see. But we're very careful this is actually an image, it's a camera taken with a digital camera with filters, but we're very careful to make sure we preserve all the information and not mislead you. However, because you don't have infrared eyes, we do have to use colors that our eyes can actually see. So you see this translucent effect looking into the center of this.
Let's take a phone call. Arlington, Virginia. This is Robert. Robert, thanks for calling. Go ahead.
Yes. What factor is time in trying to assess whether there might be other civilizations out there existing at the same time as us. It would seem mathematically that the odds are great because there's just so many stars, etc. But not necessarily so that we're developing, that other civilizations are developing at the same exact time as we are. The calendar.
Robert, that's a great point. Thank you very much for the phone call. The other distinction we should make before you answer that is, you're not saying we're going to find intelligent life within 20 years.
Yes, I mean, we are going to be looking for the effects of life on the atmosphere, and we won't know if it's intelligent until we take another look, and a friend of mine once says, well, if we see pollution in the atmosphere, we know they're not intelligent, So, but it was a very good question. The most interesting thing about this is you have to think of how old is our Earth? Our Earth is roughly 4.5 billion years old. That's when our sun formed. And if you look at all the stars in the solar neighborhood, they're actually slightly different ages as well. And so we would only recognize life as we know it today for about 500 million years. So that's the window that we actually understand.
In cosmic time.
And then cosmic time is not very big. And so it was a very good question. So we really don't know yet how the shift would change things, because all we know is what happened in the last 500 million years of our Earth. And so there could be shifts. But the real question, a much more interesting question from that, though, is if life's been around a long time and it was intelligent, why hasn't it reached us? Because maybe they would understand space travel, hundreds of millions of years, even billions of years. They could be billions of years ahead of us. Why haven't they visited us? And that's called the Fermi paradox, is that we haven't made it. And so actually this whole issue of time turns out to be fascinating.
What about the stories over the last week or so that it's been found that up to half of the water on Earth, as you drink a glass of Baltimore City's finest, actually predates the solar system.
Predates the solar system. Yes.
So if it's been flying around out there, picking up some elements, DNA, what have you, I mean, is it possible that the building blocks of life are just like that cloud in the Horsehead Nebula?
Yes, exactly.
Just floating around.
Well, in that Horsehead Nebula picture, in fact, we know there are molecules, quite complex molecules. We don't know there's DNA because that's clearly formed from evolution, right? But the building blocks of DNA and water appears to be everywhere. And I think that what we don't know is how what we know doesn't happen very easily. If you put all these chemicals into a bottle and shake it, life doesn't emerge. Right? So something else has to happen, and we just don't know what that something else is. We don't know what other things have to happen, but water is a pretty central part. And it was actually pretty exciting to realize that half the water was actually around before we were formed, because that tells you that at least water is everywhere, and we're beginning to discover it. We've found it in other planets now, and in the atmosphere of other planets, where we think we found it around Europa. So it's getting pretty exciting.
Let's take another phone call. This is Jay in Alexandria, and here's Jay. Thank you for calling. Go ahead.
Thank you. I know the space shuttle, before it was retired, there was a special mission to repair Hubble. I was wondering how many more years do we have before it won't work anymore, and will it be up when the James Webb Telescope is there? Very
good, Jay. Thank you.
Thank you. Great question. Well, I was actually helping out in the last servicing mission, not in space, but sitting at Johnson. And in fact, the astronauts went up in 2009 for the last mission. And they did an amazing job of not just putting in new instruments and repairing old ones. They put in new batteries, new gyroscopes, and even put new thermal blankets on the outside of the Hubble. So ultimately, the Hubble, we think now, can last till 2020, at least to overlap with the James Webb by at least a few years. So far, it seems to be aging very well.
Around here, we like to think that Maryland is the center of the universe. And in terms of the Hubble universe and the Space Telescope universe, it is, because you're based over near Johns Hopkins. And the Webb telescope, you were telling me, is under construction physically down at Goddard.
At the Goddard Space Center. So in fact, all of these major missions, the Hubble, the Webb, these are Maryland activities, and everybody who runs the Hubble and building the Webb is actually based in Maryland.
A lot of jobs. Let's talk to Edward in Baltimore City. Edward, thank you for calling. Go ahead.
Through thousands of years of ancient civilizations, none of them had anything in common except for one thing: the Orion cluster. Why, in your opinion, do you think the Orion cluster was picked out by these ancient civilizations as where they felt like life has come from?
All right,
do you have an opinion on that?
Thank you very much. So when you look up at the sky, if I'm getting this, we connect the dots, and you get the Big Dipper and the Little Dipper and all that. And the Orion cluster was notable?
It's notable, I think, because it appeared fuzzy, not quite point-like, on a very, very clear night. If your eyes are better than mine are today, you can actually see a slight fuzz. And I think the other thing about the Orion, in certain parts, it can be seen both from the North Hemisphere and the Southern Hemisphere. So it is one of these constellations, that...
When you look at it with the Hubble compared to all these other areas, is there anything different, anything unique?
I mean, it looks much more like that, a vast... an expanse of colored gas. The Horsehead you've just seen is just part of it. It's a huge complex of young stars forming. And in fact, we've even built, you can go to our website, a 3D model of flying through the Orion Nebulae, which you can actually do. It's a very different view, but it actually is one of these ancient, you can look all the way back, and when people actually identified constellations, the Orion is always there, and his sword, it's certainly in the Northern Hemisphere, and to some extent.
Interesting. Let's take a look at one more photo from the folks over at Hubble, and this is recent as well. We're going to go forward for the shot of, I think it's not Neptune, it's one of Jupiter's moons, and I confuse that all the time, with a geyser of water. So obviously this is something that was very faint that's been enhanced a little bit. What are we seeing there?
Well, this was a remark. Europa is one of these sort of mythical moons of Jupiter. People write books about it, Arthur C. Clarke. It's believed to have this big ocean of liquid water underneath it. And the gravitational...
Who first guessed that?
I don't actually remember, but it was in 2001, so it was at least back in the 70s when you wrote that. I think because they sent the Cassini, the Voyager spacecraft went past it. And the idea here is that as it goes around, the gravitational flexing with Jupiter keeps the water liquid.
On the inside.
On the inside.
It looks like an ice ball from the outside,
it's
because it's like a snowball.
It is like
somebody's constantly squishing and molding,
and the radiation is annealing the surface and so forth. And so we've always wondered: is there life? What's inside this water that for millions of years has been kept warm and liquid? And as you're saying, all these chemicals appear to exist. So is it possible to have life? The exciting thing about these geysers that Hubble discovered about a year ago was that we suddenly saw these geysers appear through cracks in the ice. And so it's possible that we're getting access to the ocean, and the water's coming up through cracks in the ice as the planet flexes. And if we could fly a spacecraft through it, maybe we can see if there's life in there. So that's why people are excited about it.
And this is in our backyard. This isn't sending a spacecraft 25 light years away, or...
No, this is in our backyard. Let's think. It'll take about 7 years to get there, the way our current technologies are. But then you could fly through it, perhaps with a little sort of electronic version of microscope, and see if you can see any bacteria or anything else, or algae moving inside the water.
Fascinating.
That would be fascinating.
Let's talk to Steve in Baltimore City. Steve, thanks for calling. Go ahead.
Yes, I'm kind of modifying my original question. Are we reasonably certain there are no planetary bodies orbiting our closest stars, Alpha Centauri A, B, or C?
Thank you very much.
That's a very, very, very good question. In fact, we have seen the wobble of Centauri A or B as though there are planets there. In fact, we've been using the Hubble recently to actually look to see if we could see this. The problem is it's it's not just one star, so it's a very complicated orbit. But we don't know yet, but it would be incredibly exciting if there was planets there, because it's only about 4 light years away. So you could even imagine ultimately sending a spacecraft there. It'll take a little bit longer. So we're still looking with the Hubble to see if we can actually see evidence of the planets around Centaurus A, but it would be fascinating if there was, because then the James Webb would have the power to actually look at the atmosphere of those planets if they existed. So the answer is we don't know, but we're having a darn good look.
Paul in Baltimore City. Paul, thank you for calling. Go ahead.
Hello?
You're on.
I want to know if this is true or not. I heard on the news about a year ago that one of the planets, one of the rings, say it's Jupiter, it doesn't matter, that one of the rings abraded. You ever hear that?
One of the rings, what, sir?
It's actually braided. They said on the news that one of the rings is braided. It couldn't get over it. You ever hear that? I was wondering if you ever heard of that.
I'll ask. Thank you very much.
Well, I'm not actually an expert in in our local solar system. However, there are round Saturn, which has this big dust ring. If they look in very, very high resolution, they did actually see, this was the Cassini spacecraft, waves of dust going around it that looked like braids. So it actually does look like it's braided. It's not because it's braided, it's because of instabilities in the actual ring create this twisted dust-like structure.
I think I saw that story. And the thought was that maybe something had been wiggling
through it or some, and so, yeah. So it definitely looks like braids, is what I remember too.
Let's go out to Berkeley County, West Virginia. Butch on the line. Thank you for calling. Go ahead.
Hello, I'd like to know if there's actually a physical end to the universe, and if so, what would be at the end?
It's a perfect question. You'd like to know that as well,
I
wouldn't
would
you?
too, yes.
Yeah.
It's a very good question that we get asked a lot, and the answer isn't very simple. The first answer is we don't believe there is an end to the universe per se. The problem is that the universe started in this very infinitesimally small space, and then through expansion, through something called inflation and then the Big Bang, the whole universe expanded. And so you have to think about, if you were an ant living on a balloon, where is the edge of the universe? Because you just keep crawling around and around. And we think the universe is a bit like that, but in 4 dimensions rather than 2. And so at the moment, there is a visible end to what we can see. We can only see back 13.7 billion light years, and we don't know what happened before the Big Bang, and we have no evidence, we have no information. And so it's a rather, it's not a very satisfactory answer, but the real answer is that we really don't know, but we believe the universe is what's called flat and doesn't really have an edge in that sense, as long as you could think in 4 dimensions, which even astrophysicists struggle with.
You were telling me before the program that we'll learn a lot more when the Webb telescope goes up in a few years, because it'll be able to see further in terms of infrared light.
Right.
It'll be more sensitive. That means you can go further back in time.
Right.
And do you have a sense of, you don't know till you look,
We don't really know. It's called the Dark Ages. The period we're going to be looking at is right at the edge of our observable universe, because as the universe expands out, the light gets stretched and the light goes to further and further infrared wavelengths, and so the Hubble just stops seeing galaxies. And there we believe there are a whole set of young galaxies that formed when the universe was first formed that only can be seen in the infrared with the Webb telescope. So we don't quite know what we're going to see, because it's called the Dark Ages, and we can see probably back within 200 to 300 million years of the Big Bang.
Let's go out to Loudoun County, Virginia. Kevin on the line. Kevin, thanks for the call. Go ahead.
Hi, I remember Carl Sagan's programs many years ago, and I think it was Carl Sagan that came up with the first equation that had the possibility of predicting the number of planets that might have life. Am I correct?
Carl Sagan talked a lot about this equation. It was actually called the Drake equation, which was a radio astronomer who tried to put all the parameters together to work out how much there would be a civilization, I should say. And Carl Sagan used that very effectively to try and work out how many planets might have life and what kind of civilizations are. Believe it or not, we are now today using that Drake equation again, because we've learned so much about astrophysics in the intervening 40 years that many of the terms in the Drake equation we can now answer. For example, we now know how many planets there are in our galaxy. We know roughly how many Earth-like planets. What we don't know is, do they have life? And that's the next question.
So what happens if we're able to fly through Europa's moon a decade from now,
right,
and we sample something and there's clear evidence that there was some sort of microscopic
yes.
life? How does that change the world? We haven't found intelligent life, but you would think the odds of it just went way up.
It went way up because suddenly it appears that life can form in completely independent environments. There's no way that the inside of Europa can be coupled to what the Earth is. For example, if we found life on Mars, it could have been contaminated because material goes back and forth. So that would suddenly tell us, oh, life's a bit more common. That means there's at least another body. And so now you come into this Fermi paradox problem. If life is so common, where is it? Why haven't they come to visit us? Maybe intelligent life is really hard to do. That would also tell us that if we looked out at the stars and those other planets, we have a much higher probability of finding life on another star if we found life around Europa.
Dr. Matt Mountain of the Space Telescope Science Institute. Sir, thank you for coming by.
It's been a great pleasure. Thank you.
We appreciate the time. Thank you for joining us for Direct Connection. For all of us at MPT, I'm Jeff Salkin. Have a good night.
This program was made by MPT to serve all of our diverse communities.